All right, in this video, we're going to look at how to solve trigonometric identities or trigonometric inequalities. So we're looking at if we have an inequality where f of x or our function is greater than, could be greater than or equal to 0, and then also when it's less than or could be less than or equal to 0. So first we want to set our function equal to 0. So we're going to set f of x equal to 0, and we want to solve for x. And we may need to factor to solve. If we are struggling by factoring, that is something that we're going to have to review. For step 2, we want to create a sign chart for solutions that we got in step 1. And we want to include any domain restrictions if we have those. Step 3, we want to test a value in one of the intervals by plugging it into the factored expression to see if the result would be positive or negative. Step 4 is that we will label the remaining intervals, and then we want to interpret the sign chart to answer the inequality from the given question. So looking at example 9, it says, what are all values for theta for 0 is less than or equal to theta, which is less than or equal to 2 pi, for which 2 sine squared of theta plus sine of theta is less than 0. So this interval just means we're not going to have to add all of the values like the 2k pi, 2 pi k. We're just looking at one length of a period, so from 0 to 2 pi. So the first thing I want to do is I want to take this part of my function and set it equal to 0 so I can start by solving. Now looking at this, I do notice that I have sine squared in my first term and sine in my second term. So they do have that in common. So I want to think of sine of theta as my GCF. So I'm going to factor out sine of theta from both terms. So if I had 2 sine squared and I take out sine of theta, I'm left with 2 sine of theta. I had sine of theta. Take out sine of theta, I'm left with plus 1. And that's still equal to 0. Now that I have factored form and it equals 0, I can split this apart into 2 separate equations. This first part here, I'll have sine of theta equals 0, which I can go ahead and solve, but I want to set up my second equation as well. My second equation comes from inside my parentheses, so my other factor. So I have 2 sine of theta plus 1 equals 0. Now I can solve each of these. If I want to get theta by itself, I want to undo this sign. So I'm going to take the arc sine of both sides, and I'm just going to write it like this. Arc sine and sine will end up canceling, so I'll have theta equals arc sine of the right-hand side, so arc sine of 0. Arc sine of 0 is asking at what angle has a sine value of 0. And if we're not sure of that, we can use our unit circle. So I'm looking at my unit circle for an angle that has a sine value of 0. Sine is my y value, so I have one here at 0. I have another one here at pi. And then technically 1 full time around my circle would be 2 pi, which also has a sine value of 0. And if I look back at my question, 2 pi is included in this restriction for my domain. So arc sine of 0 actually gives me 3 angles, 0, pi, and 2 pi. I just want to make a note of these, so I'm going to I'll need those for later when I make my sign chart in step 2, but I still have a second equation here that I want to solve. So I'm going to subtract 1 from both sides. I have 2 sine of theta equals -1. Sine of theta equals -1/2 because I divided both sides by 2. And to get theta by itself, I'm going to take arc sine of both sides again, which just gives me theta equals arc sine of -1/2. Let's put that over. Arc sine of -1/2. I still want to look at my unit circle. So that means what angle produces a sine value of -1/2? Well, -1/2 would be in my bottom two quadrants, since sine is my y value. I'm so sorry for the glare. So I notice that I have one here at 7 pi over 6, and I have a second one at 11 pi over 6. So I'm going to write those two angles down. So now that I solved for x, this was step 1. I got my angles here. I'm going to underline these as well. Now I want to move on to step 2. So I'm going to create a sine chart with the 5 values that I got from step 1. So I got these 3 angles and these 2. So off to the side for my sine chart, I'm going to make a little number line from 0 to 2 pi, because that is my interval for my domain. Right in the middle is pi, and so that takes care of the 3 angles we got with the first equation. I do want to include 7 pi over 6 and 11 pi over 6. 7 pi over 6 is slightly bigger than pi, so I'm going to put that here. And 11 pi over 6 is slightly less than 2 pi. So it doesn't matter the spacing for this. We're just using it to figure out if it's going to be positive or negative, to see if the section of the graph between 0 and pi is going to be above our x-axis or below our x-axis. Since we want it less than 0, we actually want it to be under our x-axis, so we want it to be negative. That's what we're looking for. So what I want to do is choose a value in this interval to test, and I'm going to test it in the factored form. So we're on to step 3. Well, a value in between 0 and pi, I could use pi over 2, so I'm just going to make a note of that. And I want to take that value and plug it into factored form. So this is my factored form here. In this first part, I have sine of theta. So sine of pi over 2 gives me a value of 1. And I'll show you. I'm looking here at pi over 2. A sine value is 1. And that is positive. So I just care about if it's positive or negative overall. So that's the first sign in my first parenthesis. In my second parenthesis, sine of pi over 2 is 1. I multiply that by 2. So this is 2 plus 1 is 3, which is still positive. So I have positive times a positive, which will give me an overall positive answer in this interval. So I know between 0 and pi, my graph is above the x-axis, which is not what I want since I want things less than 0. So I'm going to keep checking values in between intervals. So moving on to this one here, between pi and 7 pi over 6, I'm going to change my color. This is kind of hard. So pi and 7 pi over 6, I want to look at my unit circle because I'm looking for an angle in here. Technically, I could do 13 pi over 12, and I could just plug in my calculator to check the sine values, but I don't know for sure if it'll be part of the non-calculator section. So somewhere over here, let's just say my angle's right in the middle. If I kind of peek out my factored form, sine of this angle has to be negative because I'm just here and there's nothing else happening to this value. So back in my notes, I know that in this interval, I have my first set of parentheses, which is negative, because now I'm looking in between here. For my second set of parentheses, I'm going to kind of peek this back. If the y value of 7 pi over 6 is -1/2, I would say an angle in here would have a sine value of -1/4. We're just kind of estimating. So if I know sine of theta is -1/4, 2 times that would give me -1/2. Well, -1/2 plus 1 gives me +1/2. So overall, this parenthesis is positive. I'm going to put a little plus sign here. If I multiply a negative times a positive, that will give me an overall negative value. So I know that this portion of my graph will be under my x-axis, which fits in with my question of it being less than 0, and I want to keep checking other ones. So I'm going to alternate colors. I'm going to go a little bit quicker this time. Between 7 pi over 6 and 11 pi over 6, I like to look. So I could really do anything down here. I like to use quadrantal angles if I can. So I'm going to use 3 pi over 2. So looking at my factored form, sine of 3 pi over 2 is a negative value. So my first parenthesis is negative. And then sine of 3 pi over 2 is negative 1. 2 times that is negative 2. Negative 2 plus 1 is another negative. So I have a negative times a negative. Well, that turns into positive overall. For my last one, I kind of want to do the same thing. 11 pi over 6 is very close to 2 pi back at the place it started. Halfway in between, I'm looking. So like negative 1/4 as a sign value. My first set of parentheses, that would just be negative. My second set of parentheses, this would still be, so negative 1/4 times 2 would be like negative 1/2, plus 1 would be overall positive. Negative times a positive is a negative. So now that I have my sign chart, I want to interpret that for my answer. When it asks for the values of theta, in which this is less than 0, I know that that's true between pi and 7 pi over 6. I do not want to include these values because it's not asking for equals 0, it's asking for in between. So I'm going to say theta is less than 7 pi over 6 but greater than pi, so in this interval. Or it could be in this interval where it's negative here, that would be less than 0, so from 11 pi over 6 to 2 pi. So this would be my final answer. We have one more example that we're going to look at, which is the very last one in our notes here. I'm going to scoot that up kind of far. So for example 10, it says, what are all values of theta in the interval from 0 to 2 pi? For which 2 cosine squared of theta plus cosine theta minus 1 is greater than or equal to 0. So I'm going to start the same way. I'm going to set this part equal to 0. So I have 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0. I'm so sorry. That should be an equal sign. Equals 0. Well, we'll just make that a thick one. So now I want to factor this. This one's a little bit trickier because I can't factor out a cosine because this third term does not have a cosine of theta. So what I'm going to do instead is I'm going to get out some scrap paper and I'm going to pretend like cosine of theta is just x. So I'm going to say 2x squared plus x minus 1 equals 0, and I want to factor this. If I factor something where a is not 1, I want to multiply those together. So I want numbers that multiply to negative 2 that add up to positive 1. I have negative 2 and 1, or positive 2 and negative 1, and since I want positive 1, I want my second pair. So then I can do the reverse box method where I put my x squared term and my constant in the diagonals, and then I have 2x and negative 1x coming from these two factors in the remaining boxes. And I'm going to factor out a GCF from each column and each row. And from this one, I have 2x, and this would be a negative 1. So I know with this factored form, I could write it as 2x minus 1 coming from this right here, these two terms. And my second set of parentheses would be x plus 1 coming from the 2 that I factored out on top. So I'm going to use this because I know that I took cosine of theta and replaced it with x. So if I go ahead and factor this, I know that it will become 2 cosine of theta minus 1 in my first set of parentheses instead of 2x minus 1, because I just kind of like changed that in my brain so I got used to it. And then my second set of parentheses would be x plus 1, and that is still equal to 0. Now that I have factored form, I can split these apart and solve them. So I have 2 cosine of theta minus 1 equals 0. And I just realized this should be cosine of theta. I'm going to solve the one on the left first. So I have 2 cosine of theta equals positive 1, and cosine of theta equals 1/2, which means theta is equal to arc cosine of 1/2. Well, arc cosine of 1/2 using my unit circle would be pi over 3 and 5 pi over 3. So I want those values. For my second equation here, I have cosine of theta equals -1, which means theta equals arc cosine of -1. And there's actually only one value on our unit circle for that, and that's just pi. So now that I have my 3 values, I want to move on to the step where I make my sign chart. So my interval is still from 0 to 2 pi. So I'm going to do that the same way. I have 0, 2 pi, and then I want to fill in my values. So I have pi over 3, and then pi, and then 5 pi over 3. So pi over 3, pi, and 5 pi over 3. So I'm going to choose a value in this range from 0 to pi over 3. I could do something like pi over 6, so let's try that. I'm going to plug pi over 6 into each parenthesis. So I have cosine of pi over 6, which is square root of 3 over 2. If I multiply that by 2, I would be left with square root of 3. I know that square root of 3 is bigger than 1, so if I subtract 1 from it, I would still have a positive value in my first set of parentheses. This should still be cosine of theta. And so if I'm thinking pi over 6, cosine of pi over 6 is square root of 3 over 2, which is positive. Add 1, that's still another positive. So I have positive times positive. So overall, that is a positive interval. For my next one, I'm looking in between here. So pi over 3 and pi. I'm going to use pi over 2 since it's a nice quadrantal angle. So pi over 2, cosine of pi over 2 is 0. 2 times 0 is still 0. Minus 1 is negative in my first set of parentheses. Cosine of pi over 2 is 0 plus 1 is positive. Negative times a positive overall is negative. Now, since pi is a quadrantal angle for this one, and because it could be equal to 0, I actually want to plug pi in instead of moving on right to the next interval. So here, cosine of pi is -1 times 2 is -2 minus 1 is negative. I don't have much room, so let me go do this way. So that's negative. For my second parenthesis, cosine of pi is -1 plus 1 is 0. Well, negative times 0 is equal to 0. So I actually want to include that value as well because the question asks for anything or equal to 0. My next interval here from pi to 5 pi over 3, let's use 3 pi over 2. So I'll show you my unit circle real quick. So between pi and 5 pi over 3, I could really choose any of these. I just like to use easy values. So 3 pi over 2, cosine of 3 pi over 2 is 0 times 2 is 0, but I subtract when that first set of parentheses is negative. Cosine of 3 pi over 2 is 0 plus 1 is positive, so this will turn negative. And then for my last interval, 5 pi over 3 to 2 pi, let's do 11 pi over 6. You could also do 7 pi over 4. cosine of 11 pi over 6 is square root of 3 over 2, which we actually did in a previous interval, but square root of 3 is slightly bigger than 1, so when I subtract 1, my first parenthesis will still be positive. And then my second parenthesis, cosine of 11 pi over 6 is positive, plus 1 is still positive. So that is positive. So for my final answer, I want to say that theta can equal pi because at pi it is actually equal to 0 because anything times 0 is 0. I also want to include the intervals where it is greater than 0. So this interval was positive, so from 0 to pi over 3. And then my last interval from 5 pi over 3 to 2 pi. And those are all of the values that will make this statement true for when that is greater than or equal to 0.